Welcome to Wes Explains Best. Today we're going to be talking about simplifying cube roots and other radicals. There's several videos on the channel already in Khan Academy tutorial or in the Kuta software tutorial about how to simplify square roots. So this video is the main emphasis is cube roots and higher. So if you need some help with square roots, there's some other resources available. But this is a typical worksheet that a teacher would give in class. Dealing with cube roots, fourth roots, and even higher than that. So this is going to be a quick tutorial on how to do this. So let's go ahead and get started. I'm just going to choose a couple. Let's start with number 2. That one looks like it's going to be a little tricky. Number 1 is a square root, so we're going to go ahead and skip that one. So when I'm taking on one of these problems, what I like to do is first I like to split the problem up into its 2 factors. So I split it into the number component and then also the variable component. If there's more than one variable, I will split that up also. Okay. Be very mindful to keep the indexes the same. You don't want to make a mistake and all of a sudden turn it to the square root. That will definitely change your answer. So no matter what it is, I'm going to do the factor tree next. Okay. So I'm going to go ahead and I'm going to factor this, and I like to put the prime numbers on the left. So 2 is my prime number. I divide this by 2 again. I get 27. 2 is prime. I divide it by 3 this time because it's not divisible by 2. And I get 9. And then I get 3 and 3 for my final 2 prime numbers. So now I have this as a factor tree. And essentially what I could do is I could rewrite this problem as 2 times 2 times 3 times 3 times 3 if I wanted to. Now, that's a little excessive, but I just wanted to show you why I can do that. Now, the whole point of doing that is so we can use the index to identify how many we need in a group. So the index is indicating 3, which means we want triples. So we want to look for anywhere we see 3 numbers. And we have 3 3s. And notice how we do not have 3 2s, so we are going to box those. Why is that? Well, the reason why is because when we multiply 2 times 2, we're going to get 4. And 4 does not have a perfect cube. What happens when we multiply 3 times 3 times 3? Well, we are going to get 27. 27 has a perfect cube root. It's 3. And that makes sense. What times itself 3 times gives us 27? 3 does. So anytime we circle a triple, a group of 3, only one of those 3s is going to escape the radical. I like to say it leaves the house. So in order to leave the house with an index of 3, you need to have 2 buddies to leave the house, or 2 more buddies, so a total of 3. You need to have a group of 3 to leave the house. If not, you have to stay home. So we can rewrite this as 3. The 3 comes out of the house, cube root, and the 2 2s stay home, and we're going to multiply anything that leaves the house together, and anything that stays inside the house together, we're going to multiply. So 1 3 leaves, cube root of 2 times 2, which is cube root of 4. Okay, and like we said, we can't simplify that. Now, when I'm dealing with variables, I take a slightly different approach. What I'm looking for is I'm looking for the biggest number of 4, the biggest number that is in 4 that can be added to get 4. So I get 3 plus 1, 2 plus 2, and that's basically it. 4 plus 0, but we're not going to use 4, obviously. Okay, so why do I do that? Well, I'm thinking of splitting this up into its biggest factors. B cubed times B. Now, I'm not just looking for its biggest factors. I'm looking for any power that's a factor of b to the 4th that is divisible by 3. And the reason why is because that's the index. And that's how the quotient rule works with powers. So I can rewrite this problem as b cubed, the cube root of b cubed, times the cube root of b, because b cubed times b to the 1st equals b to the 4th. This is where that power rule comes into play. This is why I decided to look at this. When you have the same base with different powers, you add the powers to get the new result. Okay, so I chose b cubed because we think, okay, the cube root of b cubed, what times itself 3 times gives us b cubed? Well, obviously b does, okay? Now, cube root of b, we can't simplify that any further, so that just stays as cube root of b. He stays inside the house. Now we're going to combine these two. So that was our result over here. This is our result over there. We are going to combine the two here. So what's outside of the house? Well, the b and the 3 are outside, so we're going to leave those on the outside. So 3 times b. And then what's on the inside? On the inside, we have b and 4. So we're going to multiply those guys on the inside of the cube root. So that's 4b. And this is our final answer. 3b cube root of 4b. Okay? Let's do another problem, just so you get the idea of how to use the index. So this one looks pretty tough. We're going to go ahead and do this. And plus, I typically assign my students the odd numbers, so doing the evens really kind of helps me out a little bit. But hopefully your teacher's going to assign some of the even problems. But let's go ahead and move this over here. So we have the 4th root of 162, a to the 6. Okay, now, same approach as all my other problems. What I'm first going to do is I'm going to split this up so that I have the 4th root of 162, the 4th root of a to the 6. What am I going to do from here? Factor. So I'm going to find my factors of 162. So I divide by 2. It's an even, so it's divisible by 2, and I get 81. Okay, I divide that by, let's do 3, and that's 27. That's 3, and that's 9, and then I divide by 3, and that's 3. Okay, now, what am I looking for? Well, I need to look at the index to indicate what are my group sizes. My group sizes are 4. So I need to look for 4 identical numbers, and that's the 3. 1 3 is going to leave the house, and the 2 is going to stay home. So we can rewrite this as 3 4th root of 2. And we're done with the first part. Let's look at the second one. Now, we have a 4 here. So we're going to think of what is the biggest number that's divisible by 4 that fits into 6. So what numbers added together, okay, give you 6? The biggest number is 4. That's divisible by 4. 4 plus 2 equals 6. So I can split this up into a to the 4th, the 4th root of that, times 4th root of a squared. The reason why I want something divisible by 4 is it's going to make it really easy to simplify. So I have the 4th root of a to the 4th. What times itself 4 times gives you a to the 4th? Well, that's a. This cannot be simplified. Well, we could do something later. By itself, it could be simplified. Okay, by itself, it could be at least look a little bit more simplified. But the problem is we're going to use it with this, so don't think about simplifying it yet. You want to leave it as a 4th root. Okay. All right, so we're going to combine these two now into one problem. Anything on the outside of the house, outside of the radical, we're going to combine by multiplying 3a. Anything on the inside, we're going to combine by multiplying, so 4th root of 2a squared, and this is our final answer. I hope you found this video helpful. I just wanted to give you a couple quick tools that you can take on any problem, and hopefully this makes your homework a lot easier. See you next time on Wes Explains Best.